Imagine it's 6:30 p.m., you are in Ghana,
Right.
and you've just finished this absolutely brutal 10-hour shift at an unofficial contract job at a local bank.
Which, I mean, the work is deeply menial, right? It's way below your actual skill level as a developer.
Exactly.
Yeah.
And it pays just barely enough to survive. So you walk through your front door and you are just completely exhausted.
Oh, I can only imagine.
But you desperately need a new job. So to get one, you decide you want to automate your job hunt.
Which is such a developer thing to do.
It really is. But here's the crazy part. In doing so, you accidentally solve this massive structural problem that currently causes like over 80% of enterprise-grade AI agents to just crash and burn.
It's honestly a phenomenal case study. It really shows how absolute constraints can force true innovation.
For sure. So today we are doing a deep dive into how a self-taught developer named Herbert with zero budget and basically zero energy managed to out-engineer some of the biggest AI frameworks in the world.
Yeah, we're pulling from a really fascinating stack of sources for this one.
We've got his personal origin story document, some highly detailed technical briefings, and even the direct Python code for the solution he built.
Which is a new library called dagpipe.
Right. So our mission today is to explore how dagpipe evolved from this desperate personal job hunting script into a completely crash-proof, zero-cost, large language model pipeline.
And, you know, we really want to highlight what developers listening can learn from this masterclass and what Herbert calls good lazy engineering.
I love that term so much. Good lazy.
It's essential, right? It really sets the tone for everything we're going to unpack today.
Yeah, because this was not some well-funded Silicon Valley team trying to disrupt a market.
No, not at all. This was literally one guy building purely out of necessity, just trying to protect his own limited time.
So let's start with what he was actually originally trying to build before dagpipe was even a thing.
Right, the project he called Pathfinder.
Yeah, Pathfinder. The whole idea was to build this autonomous pipeline that would run entirely on free infrastructure to find him a better job while he was stuck at the bank all day.
And he was using a pretty interesting stack for this. Grok for fast language models. Ollama to run smaller models locally on his own machine.
And a self-hosted instance of NAN.
Yeah, and for those who might not be super familiar, NAN is basically a visual workflow automation tool.
Right, you can host it yourself for free.
Exactly. It lets you connect different services and APIs together. So Herbert's workflow was actually quite complex.
Oh, it was massive. Pathfinder had to actively scrape web pages for job records, analyze these dense descriptions to see if he was a fit,
Generate tailored resumes.
write custom cover letters, and format all that output perfectly.
Which is a very fragile multi-step sequence. I mean, every single step depends entirely on the success of the previous one.
Yeah, you can't exactly write a cover letter if the web scraping step just failed.
Exactly. And that was the core problem he ran into almost immediately. The pipeline would just constantly crash.
A timeout at step 4, or a rate limit hit at step 3.
And in traditional orchestration, it really doesn't matter where that failure occurs. The result is always identical.
The entire pipeline collapses.
Right. All the work, all the API calls, the processing time spent up to that point is just completely wiped out.
Okay, let's unpack this for a second because the analogy here is just too good.
Oh, the video game one.
Yeah. If you've ever played a massive, 10-hour video game that doesn't have save points, you know the exact anxiety he was feeling.
Oh, for sure.
Because if you die at the final boss, you don't just lose that one battle, you lose the last 10 hours of your life.
You get kicked all the way back to the tutorial menu.
Exactly. And that is what was happening to his LLM tokens and his API limits. He had to start over from scratch every single time.
Rescraping the records, rerunning the language model calls that he had already paid for with his limited free tier quota.
It becomes maddening so fast.
Oh, it does. And you might wonder, well, why didn't he just reach for existing popular frameworks?
Like LangChain or LangGraph.
Yeah. Those are incredibly popular for orchestrating AI agents right now.
But Herbert found they simply were not built for his reality because they don't checkpoint progress by default.
Not in a simple, accessible way, no. They fundamentally assume that you have highly reliable infrastructure.
And a massive budget.
Exactly. They assume you have the budget to just retry the whole process from the top when it fails. And Herbert had neither of those things.
Which forces this massive agonizing pivot for him.
Yeah, he's exhausted. He's losing precious time every single evening.
So he makes this really hard call. He actually stops building Pathfinder, the actual tool that's supposed to get him out of his terrible job. And he starts building the infrastructure layer that Pathfinder needs just to survive the night.
And remember, every day he spent building infrastructure was a day he was not applying for jobs.
Talk about pressure.
So he goes on Reddit and Hacker News just to see, like, is he alone in this frustration?
And what does he find?
He finds thread after thread of developers patching this exact same structural gap with digital duct tape.
Just people losing hours of progress from a single API timeout.
Exactly. Developers practically begging to know how to resume a LangChain run for the middle of a sequence.
So he wasn't crazy at all. The entire industry was struggling with this.
And the sources actually point to this NeurIPS 2025 paper that puts hard data behind all these anecdotal frustrations.
What exactly did those researchers find?
Well, they analyzed 1,642 real-world multi-agent execution traces.
Wow.
Yeah, looking at 7 state-of-the-art open-source AI systems. They track the memory states, the handoffs between different agents working on complex tasks.
And the failure rate?
It was staggering, between 41% and 86.7%.
Wait, over 80% failure in the worst cases.
Yeah.
What was actually causing them to break down so often?
The root cause in almost every single case was the exact same thing Herbert was fighting: cascading error propagation.
Meaning one little thing goes wrong and ruins everything.
Precisely. One node in the pipeline produces a slightly malformed output, maybe just a bad JSON key.
Right.
The next node ingests that bad data, gets completely confused, and hallucinates a wildly incorrect response.
Oh, and then that hallucination gets passed to like a database integration node, which just crashes the entire system.
Exactly. One tiny error cascades until the whole structure just falls apart.
Which really brings us back to Herbert's philosophy of good lazy, right?
Yes, because laziness, in his view, isn't about avoiding work.
Right. It's about refusing to waste human energy on repetitive mechanical tasks.
Human energy is just too valuable to spend babysitting a fragile script.
So he sets out to make cascading failure structurally impossible. Enter his solution, dagpipe.
Dagpipe, which stands for Directed Acyclic Graph.
Which sounds incredibly complicated, but it's really just a mathematical term for a pipeline where data flows in one direction and never loops back on itself.
Right. And the architecture here is actually brilliant in its simplicity. The core engine of its resilience relies on something called JSON checkpointing.
Okay, break that down for us, because this is the magic, isn't it?
It is. Instead of using complex, opaque state machines that live in your computer's temporary memory, Dagpipe takes the output of every single completed step or node and writes it directly to your hard drive.
As a plain JSON file.
Exactly. It saves it right into a hidden .dagpipe checkpoints folder.
So if your 10-node pipeline crashes at node 7...
You just trigger the script again. Dagpipe sees the save files for nodes 1 through 6, skips executing them entirely, and resumes exactly at node 7.
That is amazing. And the choice to use plain text JSON is what makes this so powerful for the developer experience.
Oh, absolutely. It isn't some opaque, compiled binary file that you need a special viewer to read. It's just human-readable text.
So if a node produces a corrupted output that somehow slips past the validation layer, what do you do?
A developer can literally just open the text file in their editor, fix the typo manually, save the file, and restart the pipeline.
You don't need any special debugging tooling. You just fix the text and hit go. Now, I have to push back a little here, though. My first thought when I was reading this technical spec was about speed.
Okay, sure.
If this pipeline is constantly stopping to write plain text files to a disk after every single step, doesn't that create a massive bottleneck?
It's a highly logical concern.
Yeah.
Especially in traditional software engineering.
Right. Disk I/O is notoriously slow.
But you have to look at the specific context of AI pipelines here. We're talking about language model API calls.
Okay.
A single network call to a massive 70 billion parameter model might take 2, 3, or sometimes 10 full seconds to return a response.
Oh, wow. Yeah.
In contrast, the time it takes a modern solid-state drive to write a few kilobytes of JSON text is microscopic.
Like fractions of a millisecond.
Exactly. The trade-off in execution time is practically zero, but the reward is infinite crash recovery.
Okay, that makes total sense. But wait, what about the dead letter queue? What happens if a node just totally fails?
Oh, yeah.
Like the API is completely down, or the model keeps returning garbage no matter how many times you retry it. Does the pipeline just hang forever?
Not at all. It relies on this concept borrowed from message brokering called a dead letter queue. When a node exhausts all its retries, Dagpipe doesn't just crash and wipe the console.
What does it do?
It saves the entire context of that specific failure, the exact input it was trying to process, the full error message from the provider, and the number of attempts made.
And saves it where?
Into a special .fail.json file.
Oh, wow. So no failure context is ever lost. You could wake up the next morning, read the human-readable instructions on what broke, tweak the prompt, and the pipeline picks right back up where it died.
Exactly. So the reliability problem is solved.
But crash recovery is really only half the battle here, right?
It is. Because if the pipeline restarts and has to run heavy tasks again, how do you prevent the API fees from just bankrupting you?
Yeah, especially since Herbert's budget was strictly $0.
Right. And that constraint birthed what Dagpipe calls the cognitive router.
Which is fascinating, because most modern AI systems handle routing by using a large, expensive language model.
Exactly. They asked GPT-4 or Claude, hey, analyze this task and tell me which model should handle it.
But making an LLM call just to decide what to do next costs money and adds latency.
Yes, and here's where it gets really interesting. Dagpipe doesn't use an LLM for routing at all.
Wait, really? What does it use?
It uses pure Python heuristics to score a task's complexity.
So it just runs basic code to look at the token counts and scan for specific keyword matching.
That's it. The routing logic is entirely deterministic and lightning fast.
So give me an example. How does it know what goes where?
Okay, so if the task description contains simple verbs like fix, typo, rename, or comment, the Python router assigns it a low complexity score.
And then routes it where?
It automatically routes that task to a fast, free tier model. Think Grop's Llama 3.8b or Google's Gemini Flash.
Models that cost like fractions of a cent or are entirely free.
Exactly. But if the Python router scans the task and sees words like refactor, database migration, or multi-threaded, the complexity score just shoots up.
Because it recognizes that those require heavy reasoning.
Yes, and it automatically escalates the task to a massive 70 billion parameter model.
That is so smart.
And it gets better. If a node fails on its first attempt using a small model, the router is actually smart enough to dynamically bump up the complexity score for the retry.
Oh, so it seamlessly escalates the failed task to a more capable model just to ensure it passes.
Exactly. You only ever spend your limited rate limit quota on the cognitive power the task actually requires at that exact moment.
Which is absolutely vital when you're living on free tier providers. But, free tiers come with their own unique headaches.
Oh, definitely.
Providers change things constantly. So how does Dagpipe handle providers just randomly pulling the plug on a model?
Yeah, Herbert actually calls this the grok problem.
The grok problem.
Yeah, because free tier providers are notorious for rotating, updating, or just completely retiring models without any significant warning.
Right. The sources mention a very specific incident with Google, actually.
Yes. Google retired the Gemini 2.0 Flash model on March 3, 2026.
So if you had a standard script hard-coded to use that specific model string,
You'd wake up the next morning, run your job hunter, and just get a cryptic 404 API error.
and then you'd have to dig through all your code to figure out why it broke.
Right. So Dagpipe built a self-healing model registry to prevent this entirely.
How does that work?
When you start your pipeline, before it executes a single task, Dagpipe actually reaches out and pings the provider APIs.
Oh, wow.
Yeah, it asks Grok or Google for their current list of live models and cross-references that with your configuration.
So if it sees that a model you want to use has been retired, it catches it before the run even starts.
Exactly. It emits a clear warning to the terminal and automatically suggests the closest available alternative based on the context window and parameters.
That is so elegant. It completely insulates the developer from the chaos of provider updates.
It even pulls current pricing data from a community-maintained JSON file in the repository, so you can track your estimated costs in real time.
Okay, so you have the right model and it's active, but you still face, arguably, the most notorious issue in AI development.
Getting the model to give you clean, formatted data.
Yes, you ask for a clean JSON object, and the AI gives you the JSON, but it wraps it in like markdown formatting blocks.
Or worse, it hallucinates syntax entirely.
Right, the extraction problem.
It is universally despised by developers.
Because large language models are trained on massive amounts of code, including millions of lines of Python.
So often when you ask an LLM to generate strict JSON, it'll accidentally slip into Python dictionary syntax.
Like using a capital T true instead of a lowercase t true.
Exactly. And that single uppercase letter will instantly break a standard JSON parser and crash a conventional pipeline.
So how does Dagpipe attack this?
with a brutal 5-strategy extraction method. First, it tries a simple direct parse.
And if the parser chokes?
It moves to step 2, stripping away any markdown fences or conversational filler that AI might have added.
Sure, here is your JSON, that kind of thing.
Yeah, exactly. If that still fails, step 3 uses complex regular expressions to actively hunt for the JSON structure embedded deep inside a wall of explanatory text.
Okay. And what if it hits those Python syntax quirks?
That's step 4. It normalizes them. The regex engine actively hunts for capital T, true, capital F, false, and trailing commas.
And dynamically translates them into machine-readable JSON format before the system can crash.
You got it. And if all of that fails, step 5 attempts to safely evaluate the string as a Python literal.
But wait, what happens if the AI's output is so mangled that all 5 of these strategies fail? Does the pipeline finally crash?
It still does not give up.
Really?
It takes the specific validation error generated by the parser, injects it directly back into a new prompt, and forces the language model to try again.
So it essentially tells the AI, you gave me this exact error, here's why it failed, fix your formatting.
Exactly. That guarantees the structural shape of the output.
But dagpipe goes one massive step further, right?
Yeah.
With something called semantic output assertions.
Yes. Because a schema check only verifies that the data is shaped correctly. It doesn't check if the data actually makes sense in the real world.
Precisely. A schema validation simply asks, is this field a number? It does not ask, is this number logical?
Right.
So think about it like this. It's like an accountant handing you a beautifully formatted invoice.
Okay.
The layout is perfect, the fonts are correct, all the required fields have data in them. The schema is flawless, but the total amount due at the bottom is negative $50,000.
Oh, wow. Yeah. A naive pipeline would run a schema check, see that the total is indeed an integer, accepted, and pass that negative number downstream to your payment processor.
Exactly. It's what the sources call a helpful hallucination.
But with dagpipe, every node can have an assert function, a simple Python function that checks the actual logic of the data.
So you could write a tiny rule that says, assert that the revenue field is greater than 0.
Right. And dagpipe catches the negative $50,000, marks that specific node as failed, and forces the AI to correct its own logic before allowing that data to move forward.
It completely insulates your downstream systems from poisoned data. It's wild that what started as a duct tape script in a living room is now basically an enterprise-grade architecture.
It really is. I mean, the specifications for the current release, version 0.2.1, show 132 automated tests with 0 failing.
Wow.
It even has official certifications from the OpenSSF Best Practices Program for Security. It's as robust as software built by a 50-person engineering team.
And what really stands out to me is how aggressively accessible they're making this.
Oh, yeah. You don't even need to be a Python expert to start using it today.
Right. The sources detail this integration with Appify, which is essentially a platform where you can run ready-made cloud programs called actors.
Yeah, and the dagpipe Appify actor allows you to just type a plain English description of the pipeline you want into a web prompt.
And in about 4 seconds, running on Grok's free tier for a cost of like 5 cents.
It generates a complete working Python pipeline packaged in a ZIP file.
It gives you the full code base, the runner script, and a custom readme with the exact terminal commands for your specific operating system.
It totally democratizes the whole architecture. And if you're a developer already using AI coding assistants like Claude Desktop or Cursor,
dagpipe has an MCP server listed on Smittery.
Right. MCP stands for Model Context Protocol. It's a way for your AI assistant to directly interact with external tools.
So your AI agent can discover and spin up dagpipe pipelines completely autonomously.
Exactly. You just tell your AI, build me a research pipeline for African fintech markets, and the AI wires up the crash recovery, the schema validation, and the cognitive routing without you having to configure a single YAML file.
That is incredible. And looking at the roadmap, the foundation is apparently so solid that they are now adding concurrent execution.
Yeah, version 0.3.0 will introduce Essentio support, meaning independent nodes can finally run in parallel.
Which is huge. And because the checkpointing architecture is just writing files to disk, adding parallel processing doesn't require rewriting the core state engine at all.
Exactly. But, with all these features and roadmaps, I think the next real milestone is actually profoundly personal.
Herbert finishing Pathfinder.
Yes. He finally has the reliability layer he needed. Now he's actually going back to finish the job hunting app that started this entire journey.
It is such a remarkable full circle moment. He literally had to build the tools to build the tool.
He did.
And I think that's why Dagpipe isn't just a technical library. It's really a love letter to indie developers, to the weekend builders, to anyone relying on free tier infrastructure who simply cannot afford to lose 10 hours of processing to a random network timeout.
It fundamentally respects the developer's time and it respects their wallet.
Perfectly said.
And, here's something for you to mull over as we wrap up.
Mhm.
As large language models get exponentially cheaper and faster, the industry trend right now is to try and solve AI hallucinations and fragility by simply throwing more AI at the problem.
Right, building these complex multi-agent debate systems just to verify output.
Exactly. But Herbert solved an 80% failure rate by going backward by using plain text files on a hard drive and basic deterministic Python logic.
Wow.
It really makes you wonder, in our massive industry rush to make absolutely everything AI native, are we slowly forgetting how to write actual resilient software?
Oh, that is a brilliant question to end on, because sometimes the most advanced solution is just knowing when to use plain text.